Hello and welcome, and in this video we're going to look at specific heat capacity. Now the first thing I want you to understand is what specific heat capacity means, and it basically means the amount of energy required to raise the temperature of 1 kilogram of a substance by 1 degrees Celsius. Okay, so it's an amount of energy and that's measured in joules, and it's the amount of energy required to raise the temperature of 1 kilogram of something by 1 degrees centigrade. Now let me just explain that in a slightly better context. Imagine we've got three substances. We've got water, oil and concrete, and they are all currently at 20 degrees centigrade. Now all of these different materials have different specific heat capacities. In other words, they require different amounts of energy to raise their temperature by 1 degrees Celsius. Now it's important to mention that each one of these is 1 kg. So these three substances, we have 1 kg of each, and it takes different amounts of energies to raise their temperature by 1 degrees centigrade. And let's have a look at what I mean. So for water, it requires 4,200 joules of energy to raise its temperature by 1 degrees Celsius. Now, if I just put that amount of energy in, watch what happens to the thermometer. The wobbly thermometer. There you go, you put in 4,200 joules of energy in, temperature goes up by 1 degrees. Now in terms of the oil, you don't require as much energy to make that temperature go up by 1 degree. So if I put 2,100 joules this time of energy in, you can see that has the same effect on that 1 kg. It raises the temperature by 1 degrees centigrade, or 1 degree Celsius. And for concrete, it's different again. This time you only require 850 joules of energy, and again you'll achieve the same temperature rise but with less energy. Now equally, what I could do is I could put that back there again, take 4,200 joules of energy and add it to the oil. So I'm adding double the amount of energy. What's that going to do to the temperature rise? Well, you've probably got a clue here by looking at the thermometer. 4,200 joules, that will raise the temperature by 2 degrees of the oil, because the specific heat capacity of the oil is lower. It requires less energy to raise the temperature by 1 degree. Okay, so hopefully that makes some level of sense. If not, do rewind and go over it again, because it's quite important that you understand that. The next thing I'm going to look at is the formula that you need to use to look at energy transfers and specific heat capacities. Now the formula looks like this. It says E equals m times c times, this is a Greek letter, theta. Now you need to know what each one of these stands for, so I've just written it out for you underneath. So E stands for energy transferred, M stands for mass, C stands for specific heat capacity, and this theta stands for temperature difference. Now you are actually given this in the exam. There's a formula sheet for the physics paper that you are given this formula, and they actually tell you what each of these different things mean. But it's important, in addition to this, that you are clear about the unit. So in terms of mass, the unit is in kilograms. The specific heat capacity is in joules per kg degrees Celsius, and the temperature difference is in degrees Celsius. Energy transferred, you might have picked up from the previous slide, is measured in joules. Okay, so they will give you this formula, but you need to know what each of the units are for each, and you need to know how to use it. So I've just got a couple of examples here for you where you might be able to use the formula. So the first question here is, we've got a concrete block which is warmed up by 10 degrees centigrade. The mass of the block is 10 kg. Specific heat capacity of the concrete is 800 joules per kg degrees Celsius. You've got to calculate the energy transferred to the block. Now, using this formula, which we are given in the exam, E is m times c times theta, you'll have energy transferred equals mass times specific heat capacity times the temperature change or the temperature difference. Okay, and it's just a question of using this formula and then putting in the values. Now in terms of the mass, where do we have the mass? Well, that's right here. It's in kilograms, so the mass goes in there in the formula. Specific heat capacity tells you here the specific heat capacity is 800. Oops. So that goes in there. And the temperature change, well, the block is warmed up by 10 degrees, so that's the temperature change right there. So it's just a question of putting in numbers into the formula. So it's 10 times 800 times 10. And if you work that out, that works out at 800,000. Okay, so it's 800,000. It's energy transferred. And if you remember, energy transferred from our previous slide is measured in joules. So we have 800,000 joules of energy transferred by this concrete block. You could, if you wanted to go one step further, say 800 kilojoules, or just 800 kJ. Okay, now let's try one more question. I would suggest that for this one, you pause here just for a moment, have a go at the answer, and then I'll do the answer for you, and then you can see if you got it right. Okay, so pause here, give it a go, and then I'll fill out the answer for you. I don't know why I'm not talking here, but yes, we've got mass of 10, specific heat capacity of 2100, and temperature change, well, it goes from 18, so there's an extra little bit here you've got to do, it goes from 18 to 23. Remember, we want temperature change. So the temperature change from 18 to 23 is 5 degrees, and therefore the answer to this, let me just get a calculator out for this one, calculator. So it's 10 times 2100 times 5, and the answer is 105, what was it again? 105,000 joules. So 105,000 joules, or if you're being, or going extra steps, 105 kJ. Okay, so that's the answer. And this is very similar to a question that came up in the physics paper back in January. So this is the kind of level you need to know it at. Hopefully this made some kind of sense, but do go over it again if you need to. I'll see you again soon.